Okay, today we are going to do our second lesson on chemical reactions. Yesterday we went over diatomic elements and we went over how to convert word equations, like what is shown on the paper, to formula equations, and today we're going to learn how to balance that. So after today, we're going to be able to explain law of conservation of atoms, and we're going to balance equations using the tally method. The tally method isn't my favorite method of balancing equations. However, it's something that's kind of necessary at the beginning, and then as you get comfortable with balancing equations, you're going to kind of be weaned off of that tally method once you get the underlying concept behind it. All right, so law of conservation of atoms just means that there must be the same number of atoms on the reactant side of the equation as there is the product side. And I'll show you guys an example of that during our first example, so we don't do a bunch of examples over the same thing. Coefficients are just numbers that are in front of each element, and that's what we are going to put in front of each element when we balance these equations. Okay, so let's do our first equation. So we're going to take aluminum and sulfur and combine them together and make aluminum sulfide. So first we need to take this word equation and make it a formula equation. So aluminum is not one of the diatomic elements. So we're just going to bring it down with its symbol. And then, as I've told you guys yesterday, I prefer that you keep the plus signs aligned. That way we don't kind of miss anything. Obviously, this is a simple chemical reaction. This is one of our first days. But they do get kind of lengthy, and you could mess it up. Sulfur is also not a diatomic element, so we're just going to bring its symbol down, keep the yield sign aligned with the other one, and aluminum sulfide. So I like to look at the periodic table. Okay, so aluminum, according to the charge trend, aluminum has a +3 charge. So I like to write them up here, aluminum with a +3 charge. Sulfide, so sulfide is right here, and it is one of the elements that have a -2 charge. And we're going to do the cross method and bring them down. So we'll bring down the ionic compound. I'm sorry, I didn't do my map or whatever, but this is obviously not an element, right? This is a compound. So if it's a compound, we have to determine if it was ionic or covalent. It was a metal, so we know it's ionic. So that's why I did this. If it was covalent, we would just do the what is it called? The prefixes to name this or bring down the formula, but it's ionic, so which most of them will be ionic. Ions are pretty good at separating and combining with different ions. So anyways, this would become Al2S3. Okay, so this is the formula. This is where we stopped on the last video, and today we need to go a little further and balance the equation. So we have, according to the law of conservation of mass, there must be the same number of atoms of each element on this side of the arrow, okay, as there are on this side. So for example, we have 1 aluminum here, but we have 2 here because of this subscript. So we are going to tally method. So we have Al and we have S. So we have Al and S. So the tally method, what you would do is you have 1 over here, okay, and you have 2 over here. So you want to have these equal. So you will write 2 here, and you'll mark that out and write a 2. So here you have 1 over here, 1 sulfur. So we're good with aluminum. You have 1 sulfur here, and you have 3 sulfurs here. So what you need to do is add a 3 here, and you will have 3 here. And that's how you do the tally method. You have a 3 here, 3 here, 2 here, 2 here. So now you balance out. As I mentioned already, you're going to not have to do all of this by the time it's time to take the test. You'll just kind of say, okay, there's 2 here, I'm going to write a 2. There's 3 here, I'm going to write a 3. So it'll get easier, in my opinion. You don't always have to do the tally method. So we have lithium plus oxygen will yield lithium oxide. So if you're mixing lithium and oxygen, you'll yield lithium oxide. So this is an element, okay? It's not a compound. So, but it's not one of the diatomic compounds, so we're just going to bring it down to the element. Okay, sorry, interruption. Okay, so this is not a diatomic element, so we brought the lithium down. Oxygen is a diatomic element, so it will be brought down as O2. And then we will bring down the yield sign. And lithium oxide is not an element, it's a compound, and it's an ionic compound because this is a metal. So what we're going to do is bring the charges here. So lithium is in the first group, so it has a +1 charge, which we wrote here. Oxygen, or oxide, it's here, and it has a -2 charge. So we're just going to cross the charges down. And it will become Li2O, okay? And now to balance it, we'll do the tally method. If you don't want to, you don't have to. If you can see that, oh, there's 1 lithium on here, this side, there's 2 on this side, I need to write a 2, go for it. But until you're comfortable with it, you can do the tally method. You just count how many lithiums you have on each side. You have 2 lithiums here. Okay, so 1 and 2, that's not equal, so we need to make this a 2. Okay, so the lithiums are balanced, and we have an oxygen here. So we have 2 oxygens here, and we have 1 here. So we need to add another oxygen here. That does cause a problem here, right? Because not only did we add 2 oxygens, but we added another 2 lithiums as well. So, we added another oxygen, we added 2 lithiums as well. So now we have 4 lithiums, so we are not balanced anymore. Our oxygens are balanced, right? But our lithiums are no longer balanced, so we need to come over here and change this to a 4. And change this to a 4, so this is balanced, this is balanced. So yeah, we're balanced now. So this would be the coefficient, this would be the coefficient, and there would be no coefficient here, which is really just assumed 1. Up until now, we haven't had any polyatomic ions. So this example is going to include those, so you can see how to deal with them. I would suggest not breaking these polyatomic ions up unless you have to. So most of the examples that I'm going to give you will keep them together on each side of the yield sign. However, there are a few that you will do. I don't remember if it was on the test or a quiz or whatever, but some you will actually do have to break up, but for the most part, they're going to stay together. So I would suggest keeping them together so it'll be easier to count. So if we're sticking to the tally method, I'm just going to write down the elements or ions that we have. So iron, and then we have this polyatomic ion, we have this element, and our last polyatomic ion. We have this in our equation. So we're going to just basically count. We have iron. On this side, we have 2 irons. On this side, we have 1 iron. So we will need to put a coefficient of 2 here so that they will be equal. Okay. However, if we put a coefficient of 2 here, that means we also have 2 of these polyatomic ions. So we have 2 here, but only 1 here. So we need to do that. Just keeping count. So then SO4, we have one SO4 on this side, and we have 3 SO4s on this side. So we need to make this a 3, okay? And that will change to a 3 here, which will also give us 6 sodiums on this side and 3 sodiums on this side. So we have a problem. We have 3, this side's good, this side is good with each other, these first two. However, we have 6 here and 3 here, so we need to have 3 times 2 would be 6. I can multiply. So we have a 2 here, so 2 would cause this to be 6, so that would check out. Then we have 2 phosphoruses on this side, phosphates on this side, and now we have 2 on this side.